Let's discuss about longitudinal gradient. So in longitudinal gradient, basically ICA recommends that maximum longitudinal gradient should be 3% for A and B types of airports and 1.5% for other types of airport. So longitudinal gradient. Gradient. So in this, basically ICAO recommends that maximum longitudinal gradients, that maximum longitudinal gradient should be 3% for 3% for A and B types of airports and B types of airport and 1.5% for other type of airports for other type of airports. Okay, so this is about a longitudinal gradient. Let's move on to our next thing, which is a transverse gradient. Transverse gradient. So in transverse gradients, basically for quick drainage, minimum transverse gradient is 0.5% for rigid pavement and 1% for another cases. So in transverse gradients for quick drainage condition, for quick drainage, minimum transverse gradient is 0.5% in case for rigid pavement and 1% for other cases. 1% for other cases. Wait a second, 1% for other cases. Okay, so this is about transverse gradient. Let's move on to another thing, that is the rate of change of longitudinal gradient. So in this rate of change of longitudinal gradient, ICAO recommends that 1% for 20-meter length of vertical curve for A and B type of airports and 3.33% for CD and E types, so that is other type of airports, CDE and E types of airports. So let's move on to another thing, which is rate of change of longitudinal gradient. Rate of change of longitudinal gradient. Okay, so in this, basically ICAO recommends 1% for 25-meter length of a vertical curve. 1.5 1 point sorry 1% for 25-meter length 25-meter length of vertical curve for A and B and 3.33% for 3.33% for C, D and E types. Wait a second. CD and E types. Okay, so this is about longitudinal gradient. This is about transverse gradient and rate of change of longitudinal gradient. Let's move on to next thing, which is a side distance. What? Side distance. Okay, in side distance, basically, ICAO recommends that for A, B, and C type of airport, surface of taxiway should be visible should be visible from 3 meter of height. Surface surface taxiway should be visible from 3 meter of height. Okay, so in this ICAO recommends for A, B, C type of airports, surface taxiway should be visible from 3 meter height for 300-meter distance. Okay, and this is for A, B, C types of airport, and for D, E type of airport, surface taxiway should be visible from 2.1 meter of height for 250 distance. Okay, so for this is for A, B, C type of airport. So for D, E type of airport surface taxiway should be visible from should be visible from 2.1 meter height for 250-meter distance. Okay, so this is about side distance. Let's move on to next thing, which is turning radius. What? Turning radius. That's R. So we have formula for this, that R is equal to V square upon 125 F, where F is a transverse coefficient of friction, where F is a is transverse transverse coefficient of friction, transverse coefficient of sheet, transfer coefficient of friction, and it's generally it's we assume its value about 0.13. Okay, so this is we have this formula for turning radius, and let's talk about minimum turning radius for large subsonic jet and for supersonic transports. So for large subsonic jet, R minimum is equal to, so for large subsonic jet, R minimum is equal to 120 meter. Okay, 120 meter for any value of speed, for any value of speed. And for supersonic transports, and for supersonic transports, we have R minimum is equal to it is equal to 180 meter. Also for any value of speed. Okay, so this is about turning radius, and in the turning radius we have one more thing. So according to Hoare and Jeff, we have one more formula. So according to Hoare and Jeff, we have R is equal to 0.388 W square upon T by 2 minus S, where W is wheelbase of aircraft. W is wheelbase of aircraft. W is wheelbase of aircraft. Okay, and our T is width of taxiway pavement. T is width of taxiway pavement. And our S is distance between midway point of the main gear and edge of taxiway pavement. Basically, our edge is distance between midway point of the midway point of the main gear and edge of taxiway pavement. Basically, it is in meter, and this wheelbase is also in meters. Okay, this in meter. So this is about turning radius, and basically we have formula for S. It is about 6 plus wheel tread upon 2 in meter. Okay, so this is all about turning radius. And one last thing in taxiway design of airport engineering, that exit taxiway. Prompt for this, that the number of gate positions, yeah, formula type of thing, that number of gate positions is equal to capacity of runway, capacity of runway it is in per hour upon 16 to 2 into 16 to 2, uh, basically give me a second, 16 to 2 into average gate occupancy time, average gate occupancy time. Okay, so yeah, So there, this is all about our complete airport engineering for gate point of view. So this is all about the airport engineering. So till then, this is it for today. Till then, do a lot of more questions, lot of numericals for gate examination. Okay, okay. And till then, take care. Goodbye, and thank you so much for watching this video. Okay, bye.